Has JWST been damaged by microparticles in space? The short answer is no, but let's talk about it. So one of my favorite creators, Astra Alexandra, posted this on Threads today, asking if people thought this selfie image from JWST looked like it had signs of damage, maybe due to microparticles in space. So like I said, the short answer is no. These are just some very common aberrations that we tend to see in imaging techniques, whether it's due to the camera or mirror alignment, and just kind of general optic effects that we kind of get. For context, I'm an experimental physicist and I use lasers to image things, so I'm very used to seeing weird little abnormalities in the images and in using optics. So I just thought this was like an interesting topic to talk about. And I just want people to remember though that in Alexandra's original thread, she says very clearly that she is just speculating and kind of don't just take what she's questioning as this is a thing that has happened. So yes, JWST has not been damaged, and now I will tell you what you are seeing in this image, or what I think is going on in this image. But let's start with how this image was taken. How does JWST take a selfie? So unlike traditional cameras, JWST does not have a dedicated selfie camera. Instead, it uses a special mode within its near-infrared camera, which is the NIR camera, and it's called pupil imaging mode, and it uses that to capture images of its own mirrors. So the NIR camera includes a pinhole-sized lens that redirects light to form an image of the telescope's mirror. This provides a distorted but useful view of how well the segments are aligned. Now, there are limitations to imaging this way because since it's not JWST's primary imaging mode, artifacts such as optical distortions, internal reflections, and detector noise can appear in these images. So these artifacts do not affect JWST's actual science observations, it just affects how we're able to take an image of the mirrors themselves. So why is diffraction visible in this selfie? And diffraction are those little circular ripples that you're seeing around it. So diffraction is the bending and spreading of light waves, and it happens when they interact with an obstacle such as the edges of the segments of the mirror. It's got 18 hexagonal mirrors that have small gaps between them, so light diffracting at these edges will produce these circular interference patterns. The second thing is the mirror alignment process. Because even though JWST is fully operational in space, its mirrors are continuously being fine-tuned. So any residual misalignment between segments could cause additional diffraction effects. So imaging it this way allows the engineers to be able to determine if some realignments are needed. Now, the secondary mirror support structure on JWST is suspended by 3 struts, which we can actually see in the image. And these can also introduce additional diffraction spikes and like subtle optical distortions when you're taking an image from this or at this angle. So like I said, the image was captured using the NIR camera's pupil imaging mode, which is a diagnostic tool for alignment. It's not a high quality camera. So some artifacts could be due to the imaging system itself rather than actual issues with the primary mirror. Now, the second thing are these small black dots that we see. So the question is, do these indicate space debris damage? Well, if we zoom in and take a closer look at this image, we can see that these dark marks, they all have a very similar cross-like shape. Now, you might look at that and think it could be signs of micrometeroid damage because it does look like tears, but these dark spots appear consistent in shape across multiple mirror segments, and because they're uniform, this suggests that this might be more related to optical artifacts rather than random micrometeoroid damage, which would cause different shapes. We also have to think about the size of JWST. Remember, its primary mirror is 6.5 meters across, meaning if these marks were actual physical damage, they would represent relatively large craters on the mirror. We're talking millimeter to centimeter scale, and that would be very identifiable in the images JWST was collecting. Most micrometeoroid strikes in space are expected to be on the micron scale. Like, larger impacts are possible, but they wouldn't be this size. We also have to think about the fact that it's a repetitive pattern across the mirror. The fact that these marks appear similar in different segments suggests that they're probably from JWST's optical system, or like the camera imaging system is taking this photograph, rather than random impact craters. So to answer the question, could this be micrometeroid damage? It seems very unlikely. All of these marks are a little bit too uniform, they're a bit too large. A micrometeoroid strike would generally appear as random, irregular marks, not consistently shaped, probably much smaller as well. They also don't disrupt any of the diffraction patterns that we see in the image, and if they were actual craters, we might expect to see local distortions or phase disruptions in the diffraction rings themselves. So just out of curiosity as well, what else could cause these marks? Well, given the structured appearance of the dark spots, an alternative explanation could be things like internal optical artifacts, which is the most likely cause. This is where the pupil imaging mode used to capture the selfie is not designed for high-resolution science imaging. So these marks could just be from imperfections in the camera system itself, such as internal reflections, detector defects, or shadows. The second thing could be shadowing from optical components, possibly linked to the alignment system or struts holding the secondary mirror. It's also reasonable to assume there could be surface contamination or microscopic defects, because while JWST was kept extremely clean before launch, minor dust contamination or microscopic defects in the mirror coatings could produce similar effects under certain lighting conditions. But the major question is, could any of this affect JWST's science images? Well, we already know that it's capturing deep space images. The real concern is whether the artifacts appear in the scientific observations. But from what we understand of the current status of JWST's performance, the images so far appear clear without any significant distortions. NASA has not reported any unexpected damage affecting scientific operations, and fine-tuning continues to ensure optimal performance as far as we're aware. So, to conclude, I don't believe that there's any evidence of any major damage. The diffraction ripples in the selfie are expected due to the segmented mirror design and residual alignment adjustments. The small black dots are most likely detector artifacts, optical shadows, or minor system noise rather than actual micrometeoroid damage. Now, if there was any true damage, NASA would see the distortions in deep space images, but JWST's performance so far has remained exceptional. You guys, I am not an astrophysicist, so I don't normally talk about stuff to do with JWST, but this is just so connected to the research that I'm doing at the moment on my own imaging system, which is just so much focused right now on trying to understand the noise contributions that we get, the things that interfere with our imaging system and our detectors themselves and affect our sensors that reduce the quality or the resolution of the image that we have. So it's across physics, imaging diagnostics are a major thing, and being able to understand how these artifacts might appear, but also how they don't actually affect the data that we are collecting and analyzing depending on what's happening in the system, is really important, and something that I never get to talk about in my big old nerd life on here. So there you go. It's probably the only JWST video I'll ever make, but I hope it helped some people understand that there's no cause for concern and what's actually happening in this video. Picture. It's a picture. Sorry. This is a video. I'm still a little bit unwell. Anyway, okay. Thank you for watching. And yeah, oh, sorry. If you enjoyed this or if you like what I'm doing, then I would greatly appreciate it if you would subscribe to my channels and interact with what I'm doing. It all helps me be able to keep doing this, and thank you so much for watching. Stay nerdy.